Okay. Alright, so our last little bit. Let's see. Oh, here's okay. Well, one more question, and I'm just looking through the final that I've written here. One question related to R. If you change the, if you multiply all the numbers by a constant, that does not affect the correlation. Okay, so if you I don't know, changing, multiplying all the numbers by a constant, whether it's just one variable or both variables or whatever it might be, does not affect the value of R. Okay. So changing the scale does not affect correlation. All right, so let me, let's see. Okay, so again, for every test, should I list off all the tests you should know? I think I did that last week, right? So I did that last week. So each of those tests that I listed, you've got to know when you're supposed to use those tests. You'll have about 5 questions there. And for each of those tests I have listed, you should know how to get your hypotheses, or what the appropriate hypotheses are. You should know how to calculate your test statistic, know how to calculate your p-value, and the meaning of the p-value, or your conclusion. Some of the hypotheses are a little, not tricky, but just maybe you forget. So the hypotheses for a t-test with independent groups is different from the hypotheses for a t-test with for paired groups, right? One you have mu1 minus mu2 equals 0, the other one you have mu of the difference is equal to 0. You should know the hypotheses for ANOVA, hypotheses for test of correlation significance, and the hypotheses for chi-squared, goodness of fit, chi-squared test for independence, all of your different tests and your hypotheses. Know how to get your test statistic, know how to calculate your p-value. Let's talk about some of these conceptual things. I'm trying to think what can I tell you guys or ask you here without giving away questions too easily. Okay. Let's try out a problem. Okay, so we're going to say for a specific group, do we have evidence that there are more males than females? Let's say that's what we want to know. There are more males than females, okay. And so we go and we gather a random sample. And this is the data we've collected. We found 112 men 103 women. Random sample of 215. Does this provide evidence that there are more males than females? That there are more males than females in the population. Okay, don't shout out your answer, but think about it. What would the appropriate statistical test be in this situation? Think about what statistical test we would do, how we would set it up. Okay. What test would we use here? Chi-square goodness of fit test. Now, what would our null and alternative hypotheses be?
Null would be there's an even amount.
Okay, well, okay, so if we're talking about proportions here, or, so when you have goodness of fit, we have proportions in mind, right? So what are the proportions we have in mind? Okay, so it would be proportion male is equal to 0.5, and proportion female 0.5. Okay. These are the proportions we have in mind. Because I only have two categories, I could just write that we will say P will be the proportion male. So my null hypothesis would be that P is equal to 0.5, and the alternative is that P is greater than 0.5. Okay. We're asking if our random sample provides evidence that the proportion is greater than 0.5. Okay, so how do we do our test? So what I have observed what am I expecting? So 215 divided by 2, 107.5, 107.5. So my chi-squared statistic would be 4.5 squared over 107.5 plus 4.5 squared 107.5. Get a chi-squared statistic of 0.377. I would look this up in my table, and I would get a tail area greater than, I think, 0.2. have degrees of freedom, df is equal to 1, and my tail area is greater than 0.2, so my corresponding p-value is greater than 0.1 because I have a one-tail test. Seems okay. And so we would conclude we do not have evidence that the population has more males than females.
Is that given that the alpha is like 5%?
Yeah, assuming alpha is 5%, yeah. Okay. If I asked you to create a confidence interval for P based on your sample, could you do that? Yeah, I think you just need to have somewhere in your notes the standard error and how to do the confidence interval, but it seems reasonable. Okay. Let's see. So I have in the conceptual section, all right, I have several questions or I have a few questions in there, yeah, asking, you know, the proper interpretation of your p-value and conclusion in the context of a problem, okay? Okay, so let's just use the previous example where we said, you know, we did a test to see if there are more males than females in the population. P-value came out to be greater than 0.10. So to just hide the last thing. Okay, so I might, let's say, I could write a few statements that are similar sounding. We would say, so let's say, alpha is 0.05. Okay, so I would say we do not have evidence, so there's multiple choice, so you have to choose the correct ones. Okay, so we do not have evidence that the proportion of males in our sample is greater than 0.5, or we do not have evidence that the proportion of males in the population is equal to 0.5, or we do not have evidence to believe proportion of males in the population is not 0.5, or we have evidence that the proportion of males in the population is about 0.5. Which of these would be correct? Or are any of these correct?
C's a good one. And the first one.
First one?
We do not have evidence for the proportion.
But you mean
Oh.
point oh five though, right?
Oh, 0.5, right.
0.5. I'm saying 0.5.
Oh, yeah, C.
Does it need to be greater? Greater than 0.5?
We do not have
Evidence. Of the population.
Yeah, I would say this one's acceptable. Okay, this one's good. All right. This one is not correct because it's talking about proportions in our sample, and we're always talking about. I mean, we have evidence that our sample is over 0.5 male. And these ones are just kind of jumbled up. B and D, they're similar sounding, but they're jumbled up. So we have, at the end of our conclusion, we had no evidence to reject the null hypothesis, which I've deleted. So the null hypothesis is that P is equal to 0.5. So we have no evidence to believe that this is wrong. Okay, so we don't have evidence to believe that the proportion of males in the population isn't 0.5. Okay, so we had no evidence to reject the null, so that would be okay. Or if I said that we have no evidence to support the alternative, that would also be okay, right? But I'm gonna, I don't know, students complain that my things are worded funny, but that is also a little bit intentional. Just to make sure we understand what we're saying.
So it's the third one?
Yeah, this is the correct answer. This is the correct answer. It is choice of four. Okay, so of course you're not going to see this exact problem, with something similar, okay? Do you remember the problems relating the confidence interval to a t-test? You'll have a problem like that. What does it mean? So this is not the exact question, but keep in mind, what's the difference between a directional test and a non-directional test? What happens if it fails the directionality check? How does that affect your p-value?
There is a p-value?
There is a p-value.
It's more than.
But you don't continue.
Oh, it's more than, so it's not applicable?
So if it fails the directionality check, we know what? We know immediately that we have no evidence to support the alternative. So that means for sure our p-value is going to be greater than alpha. And in fact, if it fails the directionality check, we also know our p-value is greater than 0.5. Okay. If a test fails the directionality check, we know for sure the p-value is greater than alpha, and we will also know the p-value is greater than 0.5. If we fail our directionality check, we will not reject the null, and we have no evidence to support the alternative. We never say we reject or don't reject the alternative. We only talk about rejecting or not rejecting the null. We only talk about supporting or not supporting the alternative. So that's actually good to know. How alpha and beta, type 1, type 2 errors are related, and when we would want a large alpha versus a small alpha. I think these are challenging but fair and good questions to ask regarding conceptual stuff. And I feel like this is it's lengthy, but it's a good final. I don't
Do
know.
you have conceptual questions from the first part of the class?
Like 1 or 2, okay?
What about calculations?
No calculations. No calculations from the first half of the class.
At all? No calculations at all?
Right.
If we have questions, can we just email you or?
Sure. I would probably post to the Facebook, I would say. Would be better. Or yeah, if you don't have Facebook, you can email me, no problem. Okay, we'll see you guys next week. Good luck studying.
Yes.